Hey you too, what's up? So today I'm going to show you how we can work out the equation of the circle that passes through three given points. Of course, you need to be given the coordinates of the points, that's necessary step. And like in this problem you have 3 points, C, D, and B. You're given the coordinates and you need to be able to work out equation of the circle. So this is typical problem and questions, maybe a part of more complicated problem and questions related to A-level or IB programs. So that's why all those students of those programs are welcome, all right? And this is also the general math problem, so students of general math education, so you're welcome as well. All right, so just grab your notes, grab your pens, and maybe you know the steps, maybe you know approaches, but I just want to a little bit diversify your way of thinking. So that's why I'll just try to show several approaches that might be eligible here. I show you drawbacks, cons and pros for each one, and let's get started. By the way, if you're new here on my channel, if you're new subscriber or just new watchers, so don't forget to put the likes, of course, smash that like button, and don't forget to be subscribed. Also, don't forget to check out my dance channel, so you can type Daniel Dallas on dance on YouTube, all right, and you'll find my channel related to dance. There are lots of dance tutorials and just my dance clips. All right, so let's get started. The way one, so the standard way, a standard approach. So I'll set up the equation of the circle in the standard form, x minus x0 plus y minus y0 squared equals to the radius of the circle squared. All right, coordinates A, which is the center, are x0, y0, hope you know that, and r is the radius. So this is the radius of the circle. How many parameters we need to define in order to get this equation? We need to define 3 parameters. So 3 unknowns means that we need to have 3 equations. 3 equations that allows us to find those 3 parameters. So that's why what we need to do, we need to, of course, the way one, to plug each coordinates that our circle passes by through, okay? C, D, and B, those points, C, B, and D, we need to plug those coordinates into the equation of the circle, in this general equation, instead of x and y, of course. Because we know the coordinates, we can plug, take into account the fact that this circle passes through the point. So this is available for the function. This is not a function, as you remember, this is a relation. However, it still allows us to plug the coordinates. So we can plug, for example, coordinate of point B, because they're whole numbers, integers, 2 and -2. So that's why we can plug those coordinates instead of x and y. Let's see how it works. I just want to show you the general approach here. So B coordinates, so that's why it's going to be 2 minus x0 squared plus y minus, instead of y, we also plug -2, so -2 negative y0 squared equals to r squared. And we've got the first equation by plugging B coordinates. So next we need to plug C coordinates, we need to plug D coordinates, and finally we get 3 equations. We combine them into the system of equations that allows us to find a solution. However, if you have a look at the form of the equations that we got, you understand that it's going to be pretty tricky to get this, right? Because they're all quadratics, and this is insanity to solve it manually. If you have GDC, of course, no problem. You can go to the equation solver and attempt to solve that, or you can just find any online software that use numerical methods or analytical methods, and you can solve. So that's why way one, which is the straight way by plugging 3 coordinates of those 3 points, allows you to find a solution. However, it's not for manual solution, right? Just remember the problem that we solved before, where there were two tangent lines touching the circle, and of course, trigonometric approach was pretty easy, all right? So that's why I will switch to way 2 and try to demonstrate how it can be solved using maybe easier methods, easy in terms of technical execution. Maybe the methods is not really easier, just guys, you judge the complexity of the method I use. All right, so what I propose, I'm going to use the fact that if we connect our points with straight line segments like this, we will arrange triangle. This triangle is random. As you remember in the previous problem, problem 3, we had a specific triangle which was right angle that allows us to say that, for example, if angle B was right angle, right? If it were a right angle, CD would be a diameter, right? According to the fact that right angle, inscribed angle with 90 degrees, which is the degree measure of the angle, allows us to judge that CD is diameter and center is on it. But we have general case, how to be there. Of course, we are gonna, I want to have a reference to the theorem that allows us to say that the center of the circle, in this case A, is the intersection of perpendicular bisectors from each side of this triangle. Okay, so in other words, what we're gonna do, we need to put, first of all, find the midpoints for each side. That's not going to be a problem, right? So because, for example, if you know the coordinates of C and D, you can work out M is midpoint, M1 midpoint, and you can do with all other 2 points, all right? So you know the coordinates, right? So the coordinates are known numbers. So we work out just by adding C and D, x coordinates divided by t, and the same for y, right? So yc plus yd and over 2. So that's why we can define m1, m2, and m3. There is 3 midpoints. So what's the next step? Because according to the theorem, the center is intersection of those 3 perpendicular bisectors. So that's why I will set up L1, L2, and L3 of those lines that contains those segments M1, let's say A. So I just clarify. So L1, for example, is the line that contains the segment M1A, which is perpendicular to the side CD. All right, so that's why the strategy is pretty straightforward. Point A is going to be an intersection point, so this is intersection sign of 2 lines, for example, L1 and L2 intersection, right? So this is going to be an intersection of 2 lines. And to define the coordinates, it's enough to have just 2 equations of those lines, right? Because we need to define x0 and y0 coordinates. So that's why if we know the equation of line L1 and L2, that's enough, right? That's enough in order to find the coordinates of the center. Once we know the coordinates of the center, we can put the radius, for example, let it be green one. So we connect C and A, right? And this is going to be the radius. So that's going to be the radius. And knowing the coordinates of C and knowing the coordinates of A, we can calculate the distance between those 2 points. And that's going to be the radius. Okay, so that's the last step. So this is the strategy. So the main question is how to define equation of at least L1, for example. I will show you how to do that. L1 is the line that's perpendicular to segment CD. Because we know the coordinates of C and D, so we can define the gradient. So gradient, let's mark as M, right? In general equation of the line, M is the gradient, so MCD is going to be just no number, right? So we know the gradient of MCD. Let it be, for example, 3 over 4, for example, right? So the gradient of line L1, okay, is going to be a reciprocal because this line segment is perpendicular, right? It's a perpendicular bisector. So bisectors, by the way, splits the midpoint, so that's why splits of the segment CD on 2 equal halves, so that's why M1 is the midpoint, by the way. All right, so going back to the gradient, M1 is going to be the gradient of line L1, and because the gradient is going to be a reciprocal number with minus sign, so we know M1. So that's why the general equation of line L1 is going to be M1x and plus C1. All right. So we know now we know M1, how to define C1. C1 is just y-intercept. However, you can barely see that. So we can define that by plugging any random point that it goes through. So we know that the line goes through point M by plugging the coordinates of M1 into the equation of the line, right? So y coordinate of M1 equals to M1 x M1 plus C1, right? So that's why we know this, we know this, we know this, and we can define C1. So we know C1, and hence we know the equation of L1. So what's the next step? The next step, in similar way, we can define equation of line 2. So we can define equation of line 2, right? So standard gradient intercept form. So do the same with the point M2, no problem. And with the segment related to BD. So defining the gradient of BD and finding the reciprocal gradient M2. Okay, so we know two equations for line 1 and line 2, okay? We have two equations and they are linear, so that's the main positive thing, right? They're both linear, so we can combine them into the system of equations. So one more time, what we know, I just duplicate here. So we know equation of line 1, y equals to m1x plus c1. We know equation of the line 2 is going to be m2x plus c2. We can combine them into the system of equation, and hence we can find the coordinates of x0 and y0, because let's have a look at the previous picture. So we have L1 intersecting with L2, and A as the center is the point of intersection. All right, so L1 and line L2 intersect, and you solve basically GCC level, right? You solve simultaneous equations which are linear, and linear is a positive thing. So we can define the coordinates of the center A, x0, y0, and hence from here we can define the distance. So the last step is to define the distance, for example, between C and A. That's going to be the radius, all right? So easy steps, maybe they're based on the theorem, but of course, this approach will give you a preference in terms of easy solution, in terms of calculations, easy solutions. So make sure you understand both ways and you can apply that. Don't forget to watch other circle-related videos before I have explanations for the circles. So just, if you're completely new here, it's better to start from explanation, then go to revision, because right now this is the general revision for the topic and we consider a specific problem. And don't forget to solve this problem. It's very interesting to see which numbers you get and which equation you got. All right, so if you like this style of explaining on more general stuff, all right, and so that you can apply, this is definitely for those who didn't get explanation from your teachers, so at your classes. So share your comments about the way I explain if you like that new style. So smash the like button and also write the comments if you need more detailed explanation. So as I before back in the days, so just again write the comments. That's definitely significant feedback for me. All right, and don't forget to see you in the next episode. Keep on track.